Cool. All right, we're going to help you with your experimental design today. So we have a little demonstration that we started in classes with these pendulums. Experimental design means how do you design an experiment? Of course, you start with a scientific question, and then once you start with a scientific question, you start looking at how can I formulate a hypothesis, or how can I come up with an educated guess? And just be mindful, an educated guess is a hypothesis, and it should be an if-then statement, meaning if this happens, then I predict this will happen. And those this and that you're talking about is you're supposed to have your independent variable and your dependent variable both in your hypothesis. If you don't have that, then you're just making a prediction on something, and you're probably just doing an elaborated book report, which is not a science fair project, so just be mindful of that. So what we're going to look at today was how the length of the strings will determine how many swings. So the length of the string will determine how many swings. The length of the string is the manipulating how many swings we're going to have. So that's going to be the independent variable, the length of the strings. This one trial here, this one test group, this length of the string is 13 centimeters. The length of the control variable, which is a variable that's going to be compared between the two extremes here, is going to be this orange ball, and that is 26 centimeters. It's important to note because I'm going to show you a graph later on that we're going to do, all right? And this right here is the test group number 2. That is 36 centimeters, and as you can see, that's considerably longer than what we're comparing it to. So the length of the string will predict what in my hypothesis? How many what? Swings we have, which is our dependent variable. So let's take a look at it real quick. So as you can see, for the 5 seconds, as you can see, all the stands are the same height, so that means that's a constant variable. All the string type is the same, so that stays the same, which is a constant variable. All right, and because you have the same mass and the same size of the balls, all of those are constant variables, so you would list those in your project as well. Okay, so I predict that the longer the string, 5 seconds, I'll count them. 1, 2, 3. All right, 6, that's good. 6 right there, cool. Let's see what this one is here. All right, just only did one. And you would do this for several trials because sometimes you have variations in different things. So you would do this for at least 3 trials. Remember that. I'm only doing 1 trial for you now. 2, 3, 4, 5, 6, 7. Good. So as you can see, I think this was 5 or 6. This was only 1, and this was 7. Our hypothesis was right. So the longer the string, and of course we will do several trials to make sure that it came out like we predicted. If it didn't, that's okay. Your hypothesis isn't wrong, but sometimes you have to look at it and make some adjustments and evaluate it and move on from there. And I think that wraps it up for the experimental design part. We'll be back and show you what the graph's going to look like. Thanks a lot. All right, let's look at our information that we recorded in a data sheet. And the reason why I'm showing it like this because I want you to actually see me take the information that I extrapolated or gathered from my experiment, and I actually started recording the data. So as you can see, the X and the Y. Why is that there? The X and the Y, the X is because that's your independent variables. And that's what we said our independent variables are, the length of our string. And the Y is the outcomes, or how did that variable, which is the dependent variable, respond to the length of the string. So what I have here is your independent variable and your dependent variable. As you can see, the test trial, and then the control variables at 26, that had 0 swings. And of course you would do this for multiple trials. And then that has 4 swings, and then that has 7 swings. Let's look on the next sheet of what that looks like. What that looks like is going to be a dependent variable, Dry, mix, dry, mix. What does that mean? On your dependent variable is a responding variable and it's on the y-axis. This is a really good acronym to use because it allows you to see where your variables are. And also for your manipulated variables, there's also independent variable. It's on your x-axis, all right? And what that actually looks like is this. That actually looks like this. Here is what it actually looks like. This is a linear relationship. As you can see, all of the swings are here. The amount of the swings are here, which is my y-axis. My x-axis is going to have my my length of my stream because that is my manipulated or independent variable. And as you can see, there's a linear relationship, meaning anytime there's a change in the independent variable, it will always produce a corresponding change in the dependent variable. And that linear relationship, when one thing goes up, another thing goes up. So the length of the string goes up, the amount of the swings increase. So that's a linear relationship. And hopefully that helps you with your science projects, and hopefully you understand this demonstration. If not, check back with me in room 132. All right? My hypothesis was correct. The longer the string is, the more swings you'll have, and the outcome would be more swings. So you have an independent variable, which is the length of the string, and your dependent variable is how many times it swings. I think that rhymed. That was pretty good, Ms. Ebram. We're good. Thank you, hon.